Good morning, everyone. This is Dave Hammond from M.A.C Solutions, and welcome to number 4 in the KEPWARE OPC 2020 webinar series. Initially, this webinar was going to be around OPC-based data tunnels, but it's mushroomed out to also include IoT-based data tunnels now. So we'll be going through various options for tunneling data using different techniques. This webinar is aimed at people who might be doing projects that are passing data between automation systems and higher level enterprise systems, IT engineers who might be doing IoT projects, cybersecurity people who might want to understand how this will impact upon their cybersecurity policies, and anyone looking to plan such projects for the future, needing to make sure they don't fall into any elephant traps along the way. So here's the agenda. We'll be going through a little bit about typical threats, where tunnels can help, why tunnels are needed, about OPC UA tunnels, about using UA with potentially with a DMZ, how to use Data-Diodes, which is a special type of one-way tunnel, and then how you can form data tunnels using web services and MQTT. So this is more of an IoT type of technique. So over the last few years, we've seen an exponential rise in targeted attacks aimed specifically at industrial control systems. And at M.A.C, we actually sell some products which are designed to counter the threats specifically aimed at industrial control systems. This is away from KEPWARE. These are other products we sell. It's good to have encryption. It's very useful to use encryption to try to counter these types of threats when passing data across networks. But it is an arms race. There's no getting away from that. And some people have said, okay, well, the best way is to basically air gap the networks. But that's not necessarily the answer, because 72% of you have said you're already undertaking projects passing data between IT and OT. So you need to pass data. So air gapping those networks to keep them, completely ring fenced is not necessarily the way to do things. And it shows that security actually falls on multiple parts of an organization. Having the IT guys focused on security, but the OT guys not necessarily so, that doesn't really the answer. You need to balance it across multiple departments. So how do you do that? So how do you create, what measures can you take to defend yourself? The first one is defense in depth. So you can put the highest possible number of obstacles in the way. So there are multiple obstacles that need to be overcome in order for any intrusion or malware to have any effect. The second thing is you can zone products or devices into zones that have similar security requirements, and then you can create dedicated conduits, secure conduits between those two zones. And instead of using routers and switches, use more firewalls than perhaps you would normally do, because you can use firewalls to block a lot of things from happening, which switches and routers don't have the ability to do. So those are great. Those measures can be very, very effective. Another thing that is often pointed out is that security patches should be employed. You should keep as much software up to date as much as possible. That's all well and good, but those of you who are working in industries where systems are very heavily validated, that's very difficult to do. So you can't necessarily apply those patches without actually having an impact, quite a severe impact upon your validated systems. So the three that we can really make an impact upon without too much across multiple different systems are using the defense in depth, zones and conduits, and firewalls techniques. So let's look at tunnels. Let's look at the way that tunnels work and why tunnels are needed. So on the left-hand side, you have your OT system, you have your shop floor, you have your PLCs, and SCADA and your instance of KEPServer. On the right-hand side, you have the IT network where you want the data from the shop floor to go across and become information and knowledge through analysis. Obviously, you have a firewall in between. If that firewall ports have all ports blocked in both directions, obviously the data is not going to be able to get through. So how do you overcome that? Well, first of all, if you open up a single port in your firewall and allow the data to pass backwards and forwards with encryption and authentication, then you do have a link between your OT and IT with very heavily policed and very heavily encrypted and secured. And that's the way that OPC UA works. And we'll go on to look at that in a second just now. So how does OPC UA, a link between OPC, using OPC UA between IT and OT, how does that compare with the measures we were talking about earlier, the defense in depth? Well, because OPC UA has encryption and authentication in both directions, it puts up a very, very strong defense around both of those PCs. It's not a generic connection between the two, it's a very heavily policed and secured connection between those two PCs, between those two applications. The OPC tunnel is itself a very secure conduit, and the zone on the left-hand side in the previous diagram, the OT zone and the IT zone, are linked through this conduit, and the data passing through that OPC UA link is very heavily monitored, and only the authorized clients can see the server, and only the clients can see only the authorized server. So you can see it's very heavily policed in both directions. In addition to that, the KEPServer product has a plugin which is part of the core of the KEPServer called Security Permissions plugin. And next week's webinar is about that, and I do refer to it later on in this webinar as well. So if you're looking to add extra security on top of a standard OPC UA tunnel, then I would urge you to sign up for next week's webinar when we explore the security permissions in more detail. But the KEPServer security permissions, in a nutshell, gives greater granularity of security for each individual client connecting to a server. So on top of the zones and conduits, you will then have a network with firewalls. OPC UA is ideal for passing across such a network. It only needs a single port open from the client direction to the server direction, and that port can be specified by you, so you can have that as a special port across traversing your network. So a little bit of recap on how OPC UA tunnels work. So here we have on the right-hand side a PLC, and on the left-hand side we have a SCADA application. Let's assume the SCADA application doesn't have access to see the data in the PLC. It has no drivers or no OPC, no means to connect to the PLC on the right-hand side. What you will do is you will employ a KEPServer on the tunnel server side. You would employ a KEPServer talking to that PLC. So that KEPServer instance would need the drivers for that particular PLC. On the left-hand side, where your client application is, you would employ a copy of KEPServer that would have the OPC UA Client driver. And so what would happen is the data from the PLC will be being polled by KEPServer. And when a new piece of data arrives, the OPC UA Client driver on the left-hand side will be notified there's new data to pick up. It would go and collect that data and then pass that to the client application. So that's an example of tunneling with one copy of KEPServer talking to another copy of KEPServer. So that's a full tunnel, as we might call it. You can do something similar using application software on the left, which is itself an OPC UA client. So you might consider this to be a half tunnel, or just a normal OPC UA tunnel through across a firewall. So on the right-hand side, you have the PLC data being polled, and when there's new data, the client application on the left will be notified and it would come and collect it. So there's no OPC UA tunnel client on the left-hand side, it's actually the native OPC UA server itself. And the connection through the middle here is simply using a connection through a single port specified by you, encrypted and secured in both directions. Now, you can also employ a DMZ in this topology as well, because as I've said, the OPC client needs to use an open port at the server end in order to reach the server. So therefore, if you think of the IT/OT type of scenario, a firewall port will be open on the OT network to allow a client from the IT network to connect down. Now, recently in the OPC UA specifications, a feature called reverse hello has been added, which allows the reverse to happen. So this is a initiation of the OPC UA session, not from the client to the server, but from the server to each client. So that means the connection will be going the opposite direction. So if you think about your IT/OT scenario, your connection will be sent out from the OT network, and there will be an inbound port open on the IT firewall. Of course, that only changes where the port is open. It doesn't mean that no ports are open. Ideally, for many instances, it would be better if there were no ports open at all on both firewalls. So that would mean that on the IT network and on the OT network, they would need to be only clients. So in order for a client to see a client, some server needs to be sitting in the middle, acting as a relay service, and you could put that inside a DMZ. So here's an explanation about how that works. So on the right-hand side, you have your PLC drivers sitting inside KEPSERVER, so it's talking to that PLC using its native drivers. You then, on top of that, have the client driver from KEPSERVER, and you have a plugin called the Advanced Tags plugin. Now, what's happening on this PC, and this is the one that's different from normal, is you have the Advanced Tags plugin, which is pulling and pushing data between the device driver on talking to the PLC and the OPC UA client driver. And the OPC UA client driver is the driver that's initiating a connection out and pushing the data into the relay server in the middle in the DMZ. So here you have a OPC UA server sitting in a DMZ that has a copy and is retaining the copy of the data from that PLC, because that data is being pushed there by this KEPSERVER on the OT network. Now, notice that port is open from inside the OT network out into the DMZ. So you then have the ability to reach this data from the left-hand side, also through an open port outbound. So what's happening here is the OPC UA client is initiating a connection down through this KEPSERVER to this OPC UA server in the DMZ, and it can then see into this OPC UA server in the middle. Now, a bit of an explanation about what the memory driver is. The memory driver is just a series of pigeonholes which one client can write into and another client can read out from. It's a driverless driver, if you want to think of it that way. So the data is only being pushed into the memory driver by clients. There's no device driver from below pushing it up from any devices. So that's an ideal way of handling data and acting as a relay service between one client on one side and one client on the other. And that means that you've got no ports inbound on either of those firewalls. Now, some people say to me, well, that's great, but there's quite a few steps here, and if we want to make changes, then you have to manage it in multiple places. Yes, you need to manage it on the copy of KEPSERVER on the OT network, and you need to manage it in the memory driver in the middle. But if your system is very heavily locked down or validated, you don't really want changes to be trivial anyway. You want a certain procedure, quite a fixed and maybe a rigorous procedure to be taken in order to make changes anyway. So having a more complex way of making changes is probably not a bad thing. But this is a very good way of getting this data passing without any ports open. Another way of doing this, this is a a way that myself and one of the engineers at KEPWARE have explored over the last couple of years is a thing called Data-Diodes. So going back to the conventional way of using OPC UA, the data passing between an OPC UA and client and server is two-way. So you have a TCP connection made from the OPC client down to the OPC server, and that's passing data using TCP through an open port in the firewall and the OT end. So that means that the OPC client at on the IT network can pass data down onto the OT network. So it can influence the behavior of the OT network by this client be able to push down. Now, there is a way of helping that using the security policies plugin, which I mentioned earlier, and that's a way of stopping clients doing things they shouldn't be able to do. Again, I'll talk about that next week. But some people will say that what we want to do is we want only data being pushed from the OT network up to the IT network. We're not interested in anything going in the opposite direction, and we want it as secure as possible. So these types of heavily isolated networks for very secure applications, where you have data passing from the inside of the secure network to the outside, and the data being passed in a very heavily controlled manner, these are types of solution where a data diode is perfect. So a little bit about what a data diode is. Now, these have been around for a little while, and they're often referred to as unidirectional gateways. And in the past, they've consisted mostly of hardware applications rather than software applications. But you can do it using software if you know what you're doing, and this is where the KEPWARE'S solution comes in. Because it's handling data in only one direction, TCP can't be used because TCP is inherently bidirectional. So you have to rely on UDP as the transport method between the two networks. So here is a diagram that explains how the KEPSERVER solution works. So what you have on the left-hand side is a copy of KEPWARE. It's talking to the PLCs, and the data is being pushed into a special driver within the copy of KEPSERVER down on the OT network, which is a UDP client application, and that UDP client application we call the UDP transmitter. It is then sending the data via UDP across an infrastructure which is a one-way infrastructure. So this is a fiber optic transmitter connected to a fiber optic receiver and nothing going in the opposite direction. That data is being pushed up to a copy of KEPSERVER on the IT network, which is acting as a UDP receiver. So the data diode transmitter is pushing, the UDP receiver is ingesting. Now, once the data has arrived inside the copy of KEPSERVER on the IT network at the UDP receiver, the data is then sitting in the memory of KEPSERVER and then can be passed to any of the normal interfaces of KEPSERVER. So you'd have OPC applications, you'd have IoT applications, you'd have database logging applications, you could pass it onto IoT clouds. So from the perspective of these applications on the right-hand side, they'd see a copy of KEPSERVER, and they don't know that actually this data is coming from a one-way connection on the left-hand side. For all they know, it's coming from a PLC sitting straight behind that copy of KEPSERVER. So this application is a very innovative way of creating data in a one-directional path. It's also not expensive because data diode applications have commercially have been tens of thousands of pounds, very, very expensive applications to put together. You can effectively do this one for about £4,000 or £5,000, and it's a very powerful solution you'd end up at the end. So we've looked at ways of using KEPSERVER and OPC of passing data between IT and OT networks. There are also ways you can do this using IoT type techniques, and we're going to explore those now. So the first one is using a plugin to the KEPSERVER product, which is called the IoT Gateway plugin. And what that does, it takes data from the PLCs and it pushes it using RESTful messages. So that's effectively acting as a web client. This would require an outbound port to be open on the OT network and an inbound port open on the IT network. When the data gets across the right-hand side into the copy of KEPSERVER sitting on the IT network, it ends up inside the memory driver, and the memory driver then would be able to provide that to the interfaces off the back of KEPSERVER. Now, one important thing to mention here is that the IoT Gateway plugin provides an element of buffering. So should this connection in the middle between the two networks fall over for a short period, then the buffering would take care of all the data. You have 100,000 data events which can be buffered in the IoT Gateway. Obviously, that depends upon how many events you're sending as to how long that would last, whether it's 10 minutes, half an hour, or a day. But it's a fairly sizable buffer. And once the connection is re-established, the IoT Gateway will then push that buffer across. So this is a very good way of achieving a push from the OT network to the IT network without any danger of data loss for short network outages. You can also achieve a similar sort of thing using an MQTT broker. Now, this can be an MQTT broker which is present on your network and is an MQTT broker that you would put onto a PC and put inside a DMZ, which is similar to the DMZ application we looked at before using OPC UA. Or this could be an MQTT broker that is a commercial MQTT broker, perhaps on the internet. It makes no difference. The copy of KEPSERVER on the OT network will be getting data from the PLC drivers and pushing it to the MQTT broker. The way that works, it can employ SSL encryption, so that can be a very secure way of passing data across this firewall on the OT end, and that firewall has no inbound ports open. The MQTT broker itself would have the ability to buffer data, but also the IoT Gateway plugin, as I mentioned before, that also has an element of buffering inside it. So between those two things, you should have quite a good solution for buffering any data if you have network outages. On the right-hand side, you have your IT network and you have your MQTT client driver from KEPSERVER on the right-hand side. That simply goes to that MQTT broker, subscribes to the data, and gets fresh data out, which you can then pass on to applications which it's serving. So again, this is a way of creating a push from the OT network to the IT network. The difference between this one and the last one is there is no inbound port open on the IT network here. Both ports are outbound only, and you're using a middleman of this MQTT broker. So this is in some ways similar to the DMZ application we looked at earlier. Okay, so that comes to the end of the main part of the presentation. So just a recap of the agenda. We talked about the threats and the need for tunnels, traditional OPC UA tunnels, tunnels with a DMZ, data-diode applications, and then using MQTT and web services to push data between OT and IT networks. Thanks very much for watching this webinar. My name is Dave Hammond. I'm the product manager for the KEPWARE products in the UK. We also at M.A.C Solutions sell two other OPC products from Cogent, and which is the product called OPC Data Hub, and a product from a German company called InRay, which is called OPC Router. So if you want data, want to know information about how those types of applications work, then make sure you register for webinar number 10. So thanks very much for watching this webinar. Hopefully everyone is having a good day and will stay safe and well. Thank you very much.